questions? If not, let's thank the speaker again for her great talk. So next we'll have a panel discussion, and so Professor Bo Li and Professor Yi Liao and Dr. Christos Sakaridis will be on remote from the Zoom, and Professor Han Zhao and will be in person, and I'll be the moderator of the panel. Please have a seat. Oh, sorry. So before we start the panel, Best Paper Awards for the workshop. So first of all is the Research Insights Award. The paper is How Do Vision Transformers See Depths in Single Image by Peter Mortimer, Hans Joachim Wunche. Sorry, my pronunciation was terrible. And the best paper for the track 2 original contribution is Li Dongkong by Li Dongkong, You Quan Liu, Xin Li, Ren Nan Chen, Wen Wei Zhang, Jia Wei Ren, Liang Pan, Kai Chen, Ziwei Liu on the paper on benchmarking 3D perception robustness to common corruption and sensor failure. Let's give congratulations to these award winners. All right, so great. Let's have a seat here and have the panel discussion. So online we have Bo Li, Yi Liao, Christos Sakaridis, and the organizer Hong Yang is also online as well. All right, so perhaps can we show the Zoom videos? All right, so perhaps kind of maybe a high-level questions for the self-driving researchers to start is, so we've recently seen a lot of progress in terms of foundation models. Sort of gives us like insight on maybe just one single big model can do a lot of amazing things. Whereas in self-driving, we see a lot of specific modules. Sometimes they are differentiable and end-to-end learnable, but people also still like thinking really hard in terms of specific tasks as benchmarks. So what's your opinion on maybe perhaps the next few years? Will these modules become more unified and sort of merge it into a monolithic model, or here we still have more, physically grounded challenges that we will have to still build, specific tasks and models? Yeah, maybe let's start with Han in this audience, and then we'll go through the remote panelists as well.
Yeah, I can use this. Yeah, I think that's a very high level and challenging questions. I personally haven't worked too much on big monolithic models. Actually, it's pretty challenging because when we build a big model, we need to deal with all kinds of inputs and outputs. And if we want to evaluate the intermediate results, we also need to build a benchmark for that. I think Hong Yang has a great paper recently in doing that. That's really great. That involves a lot of efforts, I believe. And I think into the future, I believe this will be a big trend. Like these small models or small modules will be consolidated into larger models. But I guess at the end of the day, it will not be consolidated into one big model, but maybe 2 or 3, like perception, prediction, planning, maybe 2 or 3. Moving towards one model will be very challenging because it will really need the efforts from many different experts from different domains. For example, perception, computer vision, like behavior modeling, planning, and controls. We need experts from all these. And engineering-wise, I would say it will be very hard to deploy onto real self-driving cars. So, yeah, I guess my guess is in a real self-driving company, we still need experts to work on their domain-specific large models.
Great. Maybe let's start with EE.
Okay, yeah, I also think that's like a very challenging question. So like, I personally think, because when we think of the large language models, the key is sort of that it is really like a unified or like a unified task can be designed to merge all the tasks, like by just simply by completion, then it learns a very general knowledge. And that's sort of like a key in my opinion. And then in that sense, I would say maybe it is also important to have a sort of like a unified model, like for the automated goal for the autonomous driving, for example. And maybe in the end, this pre-training, like maybe we need one unified task, but maybe it's still possible to fine tune them for different, like more specific tasks, for example. Yeah, that's my opinion.
Great, thanks. Christos?
Yes, really interesting question, an interesting topic. First of all, from like our experience as humans, we see that all humans have the same genetic basis, but different persons, different people are better at different tasks. So it might still be that we have like a unified architecture, for example, in particular for autonomous cars, but we could have different instantiation, different weights of this model, which we want to deploy at different scenarios, different domains, for example. So it's not necessary that each car needs to have its own same model as a whole. That would be my comment. And also another aspect is explainability, because we also have in autonomous cars the legal aspects, the ethical aspects, and if there are difficult scenarios like accidents, we need to know what the car had perceived in a human interpretable way so that we can know who to blame, basically. So then in that case, we need internal representations, like as the previous panelist said, like with some concrete outputs, like vision outputs, for example, from perception, or planning trajectories, trajectories that the vehicle has decided to take. So.
Great. Yeah, I agree that interpretability is an important aspect for designing models, especially for like the regulators and for the engineers to understand internal states. And Bo, would you also take your turn?
Yeah, thank you for the nice question. I think indeed it's a very important vision question to think about in terms of the future development of autonomous driving. And to me, I agree with the previous taken, which is I think it would be very challenging to have only one end-to-end model because of the different functionalities that would be integrated or needed in autonomous vehicles, I would say. However, for different modules, for instance, like how I mentioned, like perception, control, and the prediction, in terms of different modules, it's very possible to use the similar backbone because the backbone could be large and trained with diverse modality and diverse types of data so that the module actually have like say a real world knowledge like human or things, and then it can be fine-tuned or pruned for different modules and functionalities and integrated into end-to-end pipeline. I think that's kind of my vision of one possible future, because in that case, different people working on different modules and functionalities can save their efforts, that they don't need to retrain or regenerate these foundational large models, but they can still focus on the functionality they are expert in their domain, and leverage the large model as a backbone to do what types of other creative operations to make the modules and functionality like more efficient and effective. So I think that could be one possible scenario and benefit everyone. Yeah, thank you.
Awesome. Yeah, Hongyang, would you add anything? You're muted.
Excuse me. Hi, everyone from Shanghai. So actually, we just think about how to apply the large foundation model to autonomous driving recently. Because surprisingly, we just got a bunch of GPUs, so we can have some experiments to work on with. But I'm definitely not an expert for the how to apply. I mean the LLM to autonomous driving. But in my opinion, I think there are some critical points to apply it, because this is different from the general vision where you have SAM. You have other image, like you got a bunch of images to train on. Because for autonomous driving, the critical task is planning or trajectory prediction. You didn't solely address the object detection problem, but rather you have to predict the future trajectories. So that's a very big difference from the general region or the general image domain. I mean, for the foundation model in autonomous driving, we think we need to train a video related, or you need to, given current time step, you need to predict the future environment, or at least 1 second or a few seconds of the environment. So the foundation model for autonomous driving needs to have this capability to predict the future. And another critical point is in order to facilitate the large amount of data, to let the model to be trained on a very large amount of data, you need the foundation model to work on very hard tasks, not only the perception task. I mean, one of the biggest challenge to apply the LLM techniques into autonomous driving is that we don't have that amount of data. I mean, even if you have Waymo, or you have Once, or you have the largest one, by our surveys is called the lift motion data set. I mean, this is the largest data set up to date, but it's still not the largest amount of data compared to general vision, like what they did in their domain. Not to mention the natural language domain. I mean, so even if you are equipped with LiDAR and image, but that's still a perception task. It's not hard enough. So how to resort to some large amount of data, say, how about crop some data from YouTube driving data, or to crop like street map from all over the world to build a really large amount of data for autonomous driving is also very crucial. That's just some basic ideas. Yeah, in my batch.
Thanks for sharing the insights. So speaking of the data availability, like I saw a lot of today's talk around in terms of the robustness and out of distribution evaluation. And I thought that's really interesting in the fact that we don't have a lot of training data. They're all clean and in distribution, and maybe at test time, there's something totally different. So I'm wondering, like, what will be an ideal sort of learning and evaluation scenario for this kind of tasks, right? Should we try our best to collect all sorts of scenarios, right, out of distribution, different weather conditions, train them all, and hope for the best that something more robust, more general can emerge? Or should we design maybe more smarter like model priors that, you know, like automatically can be transferable to different conditions? Yeah, so what's kind of your thoughts? Maybe let's start with the other order, like Bo can start first.
Okay, yeah, that's a great question. Indeed, that's a question like bother me all the time. So that's why we did things from like the scenario generation, where I believe in terms of testing, we do need those corner cases out of the domain distribution cases. But when generating those, we need to be careful, make sure that those cases, all those scenarios actually aligned with real world and realistic, and we need to have quantitative metrics to measure the realism, the safety critical, and all kinds of like the functionality, equity level that I mentioned in the talk. So I think that's important. But in terms of how to quantitatively make the models more robust or safe, only training on this would be helpful, I observe from the experiment. But as you said, I don't think that's like the end of the story, because you can, like in typical security world, you always have this cat and mouse game. You have more like training, you have more attacks, more scenario, you have more training again. So it never end. That's why we work a lot on the certification side. Although the certification side currently is relatively toy, still like the constraint is limited. You can only do like certification against some parameterize the semantic transformations, etc. But I think some effort along this line, first of all, I believe could help to ensure, like, give us guarantee on how safe each vehicle is or each algorithm is, so that we can, know where to go rather than only based on their empirical robustness. That's first thing. And second thing, in terms of algorithm-wise improve their like safety or security against different attacks or even based on certain certifications, I think different like optimization is needed, not only training, but also the so my view is that we need to integrate human knowledge and logical reasoning, not only data-driven. So a large line of our group work is mainly focused on data-driven model plus knowledge-enabled logical reasoning, so that those knowledge reasoning itself can serve as a wrapper for any, algorithm, data-driven algorithm, so that whenever something is going on wrong, you come back to the knowledge and understandable level and can regularize it. For instance, you can pass all the traffic document into logical rules and then make sure the behavior will not violate those rules at least, right? And then it can be much safer rather than only data driven, because we don't totally understand what's the outcome of the purely data driven models, right? So that's like some perspective. I think there could be others, but indeed, I think the short conclusion could be training against those purely may not be enough eventually. Yeah. Thank you.
Great answer. Any other thoughts? Maybe Crystals?
Yes, sure. So one part is, at least from my side, where I mostly work on perception, and I think we need to pay more attention to the uncertainty that our models have, because for what I presented, for example, we just want to predict like a single value for the depth, for example, or for the semantic label of each pixel. But we have also done some work and we want to continue working. And I think the community needs to focus on having, at least from the perception side, better probabilistic output that can then be consumed by the downstream planning and control part. So not just having hard outputs. One thing is this. And the other, continue for what Bo said before, we need to basically, from the perception side, make sure that our predictions are physically feasible. So there is no reason, no, let's say, logic in predicting that there is a patch which is sky within the road. So then basically you know that this cannot hold in practice. So we need to exploit the fact that our models, our agents are really embodied in an environment and they come with certain constraints. So we know some, for example, some odometry measurements, some inertial measurements for these sensors for the cars, and we need to basically inject the constraints that we can extract from this knowledge into our model design and model training.
Great, thanks. Any other want to take this question, or I'll move on to the next one? All right, so I think boss answer on the knowledge and reasoning inspired me a lot. So I also see a couple works today on using language model for in some aspect of self-driving. I think Jamie's talk, he presented using language model to describe videos, and in Bo's talk you use ChatGPT to generate scenarios. I think these are really interesting, emerging examples how we can use the knowledge from language model to see what will be the future, what are other possibilities of sort of using language model as interface in the self-driving task. Anyone? And I'm not gonna designate order.
Okay, I'll probably start first because I'm still thinking, but I haven't talked with many people about this. One of the difficulty of applying the ChatGPT into autonomous driving is that ChatGPT is a generative model. That is, it behaves like a human. It doesn't care too much about the accuracy. I mean, but for autonomous driving, you need to output a steady, a stable, accurate output. Your value, your output value cannot change too much for the online, road test. So that kind of formulation, in ChatGPT is kind of weird if we directly applying the LLM into the the daily drive test. So maybe that's why if we just take a first step of applying the LLM, the prompt learning or tokens, that kind of concept, start with the motion prediction, because motion prediction is a sequence. It can behave or resemble like the prompt or the words sequence. But in reality, you got a bunch of raw sensor inputs. I still don't quite understand how to applying the LLM smoothly into autonomous driving. Yeah, it's kind of messy in my mind.
Nice. Yeah, any?
Yeah, I can add some words. I agree with Hongyang that this is a very challenging and messy thing because, as we know, the large language model, the interface, in terms of input and outputs, they are all languages. But for our embodied tasks, our inputs are sensor data, our outputs are trajectories, or discrete actions. So they are totally different from these language models. So I guess directly putting language models into this pipeline will be very challenging. So I think a possible way is to try something like PaLM. There's a paper published by Google. Basically, they need to tune the large language model a lot so that it supports multi-model input. But in PaLM, the output is still language description of actions. I think that's still not ideal. So I see some very initial attempts or efforts, but I don't think this will be the final final look like in the end.
Great. Anyone else have any insights on how to use language in self-driving?
Yeah. So I would like to share some ideas that we recently have, because we're all excited about huge advances in the foundational models and also the ones that use language. Language is an obvious way because it's like a very, very easy way for humans to communicate to the machines. So instead of trying to draw polygons for annotations, you can just basically talk and then let your model find out the exact boundaries or the exact configuration of your labels. So we are currently thinking in my group to use language as an alternative form of supervision or labeling. For the beginning, it can be just something that is generated automatically based on the knowledge that we already have from the ground truth labels that have been generated for existing datasets. But then this can be, streamlined and used to facilitate the annotation, because for tasks like pixel level prediction, it's notoriously slow to get the annotations. And there is a lot of progress, but I think the large language models will revolutionize this area.
So when I drive, I tend to not think about language. I just kind of having my internal reflex of recognizing object and going forward. But I think language is also a great tool for reasoning and thinking about these scenarios more. I'm pretty interested in the examples that in both presentation, that there's ChatGPT going really deep into generating these scenarios.
Yeah, indeed. One quick thing I want to add is that indeed maybe we can view those large models as an assistant rather than the end-to-end algorithm itself. For instance, from the generation perspective, we use ChatGPT to generate, as you mentioned. So it's just an assistant for creating those scenarios, but it's up to us to use our algorithm to test. And for example, as Adam mentioned, we can use it as an assistant to query and to give weak supervisions or give all kinds of guidance. And then backbone, we still have our pipeline, understandable control and algorithm. I think that would be helpful as a knowledge bank, for instance.
Yeah, that's great insight. I saw you unmuted, so you want to add something?
Yeah, maybe. Yeah, just a quick comment. I also think it's super challenging comparing to the large language models, where the input is also language, and where the input and output, they are both language or words. But in contrast, in autonomous driving, the input is images, but also consider the recent progress, for example, in segment anything. This can also sort of give us the probability to transfer the image into a set of tokens. And this might actually be some possibility to move forward to make it closer to the large language model.
Right. Yeah, a lot of progress.
Yeah,
these
just
days.
a follow.
Yeah, go ahead.
Excuse me. Just a following Yi's response. I just one of the comment that came into my mind from Sam's work. And also deal with algorithm and data. In loop pipeline is that maybe we do not need a large amount of data. We need large amount of high quality data. That's why we need to introduce the RLHF. For the autonomous driving scenario, is even easily doable because you got the human driver, right? And when you do the daily test, if you have a side driver or have some mechanism, this is a very critical case or rare case, you just click the system and to jot down the critical movements and then feed backward, and then you have a evaluation model or evaluation critic, and then feed forward and fine tune the the preliminary results. And so yeah, I mean, if we just we need to run this whole pipeline, I mean, to apply to make the autonomous driving really work, I think we need high quality data and to iteratively to train the algorithm in an evolving sense.
Yes, I agree that high quality data is also important, as shown in a lot of large language model research that they found. Not only the data size matters, high quality data also matters. So I think this is also connects to my next question. So some of the kind of research in large language model gives a lesson that, you know, imitation learning, which like supervised from human text, can push us a long way forward. And imitation learning is also like a very successful paradigm in self-driving. But on the other hand, we have reinforcement learning, and we develop better quality simulators where you can also use, you know, models like NERF to edit real scenes. And this gives us an additional layer of flexibility to train agents without human supervision. And the other paradigm is, as you mentioned, Hongyang, is the RLHF. So what if, say, like we let the car drive and then use humans to intervene and give feedback? So among these paradigms, what do you think would be like the future?
Yeah, I'll probably start first. I'm definitely not the expert to tell which one is the future, but I think among these paradigms, one is the self-supervised or unsupervised, or without any deliver annotations to the data. And another is the supervised manner, as it does in the SAM or other other approaches. I mean, for the time being, for the short time, if you focus on the leaderboard or get really very decent results on a specific data set, in my opinion, you got to do the supervised learning manner. I mean, the supervised learning will elaborately tell you which target to regress. But in the long run, I mean, many researchers in this domain will chase the unsupervised or self-supervised manner, as we do in many works like CLIP or MAE or other, literally all the paradigms. But the challenge we are facing, as we mentioned just now, is what do we have this large amount of data? And if we really need this, if we really have this large amount of data, which objective function or objective do we need to build? Is it reconstruction loss, or is it a other forms of supervision, or the objective we need to optimize? So yeah, I think in the long run, we might go for the self-supervised manner. But in the short run, if you really want to get decent results, I mean, the supervised learning might be an ideal option. Yeah.
That's very practical suggestion. Any other thoughts from the panelists?
I have some quick add-on about from two perspectives, from the data and the frameworks that I just mentioned. Indeed, I totally agree that high quality data is very important. High quality in terms of diversity, in terms of correctness, things. Actually, we have some brief observation overall. Currently, like use knowledge guidance to generate the data itself, like the other way around, and then see that with a small amount of such knowledge guided data, it can perform very well compared with large, even better than large set of data, which is kind of evidence showing that the data quality is important. And in terms of that, based on this level, I think the future is very hard to predict, but I believe that we may need to consider the framework from different perspectives in terms of composing rather than pick one. Maybe we need human feedback, we need knowledge guidance, we need supervised, unsupervised learning for different modules, and how to partition. Maybe one like framework is more important on one types of modules or one types of tasks, and the other is like basically for different marriage of the technique and the functionality and the data quality and then scenario, all kind of things, so that we can build the end-to-end final framework. That's my take. And and I may have to leave in 1 minute since I have another talk in another workshop. But thank you so much for the discussion. Sorry for missing up the time.
No, thanks for the great answer. Yeah, I guess the combo package may be.
Can I add like another comment on this question? Yeah. So we need to think about, how much we want to involve machines themselves and to use machine time, like training time, GPU time, for like learning our models, and how much we want to involve humans. And the problem is that the human throughput is much lower. We have like a much higher latency in providing the inputs in order to basically, like, for example, if we want to like use imitation learning and have like a human expert to demonstrate to our model what's the correct way, then we only have very few hours. Even if we have like thousands of drivers, these cannot drive all the time, and even if they did, they still will not generate enough data. On the other hand, if we use a simulation and we have like a fast enough simulation, we can really overwhelm the amount of data that we would get from humans. So I am in favor of like trying to make things as automatic as possible.
Great. Finally, a firm stance on one side. So, do you have
I can add some words. I personally think that all of them are necessary, but it's a matter of the ratios. And my stand on the ratio is that we need around like 90% of self-supervised learning on a large amount of data, and then 9% on the simulated data. As Bo mentioned, we can simulate from our scenario generators so that we can generate very dangerous safety-critical scenarios. And then 1% on expert data, imitation learning. So I guess at the end, it might be a mixture of self-supervised learning plus imitation learning and online reinforcement learning. Yeah.
Yeah, that's very nice view on the cake paradigm, right? So having the cake, the icing, and cherry. Yes, I like that idea. Yi, do you want to add something to the question?
I completely agree with what Han just said. I actually wanted to say very similar comment. This can be multi-stage, just like the ChatGPT training, right? Where you find in the end you add this RLHF, then it's similarly. We can start with something like reinforcement learning, and then finally this can be supervised by like human, like in this RLHF fashion. And I think that's very similar to what Han just said.
Great, yeah, thanks. So probably one last question before we conclude today's workshop. So today, a lot of very amazing progress from foundation models and large language models. What advice do you have for grad students who just begin to work on, say, like self-driving, and now everything seems like AI seems to just about to get solved? So how do you cope with the stress, and how do you what kind of advice you will give for future researchers and grad students?
Mengye, what's your opinion on this? I mean, you just entered the faculty, right, recently? would you tell your students to work on autonomous driving or large foundation models?
So yeah, part of it is like giving them some projects maybe related to that, so that they don't feel like completely missing out, right? But I think like when ChatGPT came out, I sent a group email saying that don't panic, like there's still a lot of things to work on. And so like reiterating the vision of the group, right? So what we eventually want is something more general, right? Flexible, and this is not there yet, So I think in the long run, having those visions sort of directly illustrated to the student might be more helpful for them to cope with this ongoing, madness with AI. But yeah, I'm also really like, unsure what is the best strategy. So that's kind of my question to the panelists who have more experience in terms of like mentoring students.
Okay. For me, I personally think that working on embodied AI, including self-driving and robotics, is still the best time to work. It's the best time to work on these problems. So I would suggest the grad students to work on these problems in general. And at the same time, I think, as you said, they need to keep an eye on the progress on the large foundation models. These are something that academia cannot really do by themselves. So keep an eye on that progress and see if we can borrow some ideas or even borrow some models directly from them. But still, I think solving embodied AI problems is still a long way there's still a long way to go.
Yeah. Any other thoughts from the other two panelists or three panelists?
Yeah, so I feel it's not so much a difficulty, but an opportunity. And I would rather make an analogy with the past. So 150 years ago, there were no cars at all. So what happened after that is that we had a whole branch of engineering, like mechanical engineering, and so much progress and really benefit for the society. So now we don't yet know how this might evolve, but perhaps we might have some next generation of machines, and we might be able beyond like for robotics and for like making machines and humans work better together. We might have really some novel discoveries or inventions. And of course, it's important from my aspect to still learn the fundamentals well, because if you know the fundamentals, like the math, the statistics, calculus, algebra, then there's nothing to fear, really. The grad students have nothing to envy from their colleagues who are already at the companies and working on these foundational models, if they have a solid background. That's my view.
Thanks. I like the analogy of cars. I guess now we have a new branch of engineering called prompt engineering. I also like the embodied AI mentioned by Han. I also feel like these models, they take so long to train and so much data. It's nothing really like how humans learn knowledge with just very few data points throughout a continual stream of data. I think in academia, there are a lot of work still to be done in terms of understand human-like intelligence and also understand how these models work on a more fundamental level. So any other thoughts?
Yeah, for me, because I mainly work on reconstruction and generative models, especially 3D array generative models, then I've been asking this question to myself, like, what if, because currently this is not the case yet, but like if there will be like a large foundation model for 3D reconstruction or as well as 3D generation, then like what would it be? And I actually also discussed this with my students. Like we had a brainstorming, and yeah, I think that was like good to keep thinking about this. Although I may not have the ability to do this, but thinking about this, I think is still like helpful. And maybe in another way, I think like actually for some of the open source foundation or large models, actually fine-tuning them is not as expensive as I expected. For example, like ControlNet actually can be trained like using the manageable resources, for example. So like then that could also be one option, like to try to build on top of those foundation models to do our own work.
Yeah, that's a great answer. So is there any question from our audience for all the panelists here? Yes? Yes.
Thank you. Most of the algorithm that was described in terms of deep learning are really, really heavy, right? But here in Africa, we have problems with heavy models because they are not. We don't have enough money like in the West to afford all these computational resources. So the future in Africa is probably deploying things at the edge. And now, like talking about self-driving cars or everything self-driving, for example, are you researchers thinking about optimizing these models so that like high constraint devices or high constraint self-driving cars can be deployed in the global south? Thank you.
I guess I want to also sort of like add on to that question, more of not you guys, but more of how would we sort of like approach more and like getting to know like better these models so we can like maybe try to solve our own problems. Basically like where would one start from so they have like a solid understanding of what is going on? Because I guess we'll be able to solve our own problems much better than putting it on you guys.
So anyone want to start the answer? There are two questions.
Yeah, maybe I can answer the first question, try to answer the first question. I think there are two sides. The first side is that model compression, pruning, this actually has been a major topic in the last AI wave in 2013. Starting from 2013, like people just started to use GPUs and found, okay, GPUs are so useful, but GPUs are super expensive and we need to develop edge applications. How do I make use of them? So yeah, around I think 2016 or 15, there are model compression algorithms that are coming out that make it possible. I think on one side, researchers or engineers are really making efforts to make it possible. I believe that for large language models, maybe in a couple of, not a couple of years, but maybe in a couple of months, it will be deployable on our cell phones. I think that's one possible prediction. And on the other side, especially talking about self-driving cars, I think cutting down the budget on the chips or computation is not the smartest way to go because we always want our AI models to be better. Like, I don't want us, or at least for now, we don't want a small model that performs really bad and that creates some safety issues. What we want is we put more budget on the AI models and maybe cut some budgets on some other stuff. For example, sensors, for example. The LiDAR sensors are really expensive, much more expensive, maybe 10 times more expensive than the chip. Can I cut some budgets on the LiDAR sensors and put a bit more on the compute so that the AI models performs better, and as a final result, the overall performance becomes better? I think that's what we are making. What we are trying. We are trying in this direction, but instead of cutting the budget on the compute.
Thank you so much.
Anyone want to answer the second question? So just to remind, your question was how can you build models like without having to
How would one get started?
get started with building AI models? Any practical advice for the audience?
So do we assume that the person has some theoretical background on machine learning and AI, or they want to start from
Theoretical
scratch?
background, and they want to get started in building actual applications.
So my take on this is that you need, of course, to start with some pre-trained model. At least that's what I did when I started my PhD, and I was also not very familiar with the convolutional neural networks, because these were at the time in the beginning of their era of glory. So you start with something that you find out there and you try to build on top of it, because it's really hard to build a model from scratch. If you just look now at a model description, it's like thousands of lines where each line is like one layer, one module. So it goes easily beyond human understanding. And it's like the result of the continuous development and additions and modifications of many generations of models. So you definitely want to get started from something that is already pre-trained, and you can start perhaps more on the algorithmic side to see how you can make this model better from the perspective as, for example, what I showed in my talk, that you try to build some modules on top, some losses on top, that you can constrain the model and regularize it better. I think because you might not be able to have access to the huge data that the big companies, the big tech companies have. And this is also true, as was said before, for academia. So in some way, we also feel that we are not privileged with respect to people that work in the companies in terms of resources.
Awesome. Thanks for the answer. All right, so we are now at 5:30, and I think we're about time to end our full day workshop on scene representation.